So very good morning, students. So today I am with my ninth experiment. The ninth experiment is the study of input and output characteristic of an NPN transistor. Okay, so we are going to perform this thing in common emitter configuration. Okay, so these are the equipments which we are going to require. Here I have written the theory, okay, little bit, and here is the circuit diagram. You can see the emitter one is common with both the end. Okay, both the end means both the power supply. Okay, so here we can see here that the output voltage which we are getting is the VC and output current is IC. Here the input one is VBE and IB. Okay, here the voltage which we are going to use is V1 and V2. Okay, so here you can see if we are going to do the input characteristic, in that case just see here this B junction and E junction, just look here, it looks like a forward bias diode. Okay, if you look at this circuit, okay, this whole circuit, this circuit looks like a circuit having a PN junction diode having forward bias condition. So if we will perform the input characteristic, we will get a graph which is similar to that of the forward junction graph of a PN junction diode. Okay, so this happens in for the input characteristic. Now just look at this circuit for the output characteristic. Here the output characteristic is to be done in IC and VC. Okay, we are going to draw the graph between IC and VC. Okay, so now when we are going to perform this output characteristic, what we have to do, we have to keep this IB, this current, constant, remember. Okay, and when we are going to do the input characteristic now, we will perform it between IB and VB. At that time we need to keep this thing constant, this VC. Okay, we didn't need to change this thing. Okay, we are not going to change any voltage here. So since we are not going to change any voltage here, this VC would not change. Okay, and in output characteristic, as I have told you, this IB should be kept constant. Okay, this thing I have written in the procedure also. I have written here that firstly we are going to keep the VC constant in the input characteristic. Okay, so we'll keep it constant at 0 volt, and we will take different values of VCB and IB at different values of V1. Okay, similarly again we will take another set of observation by keeping VC at constant 1 volt. Okay, and that time also we will take different values of VCB and IB there. Understood? So these things we will do in the input characteristic. Just see here the observation table is here. Okay, we will change the V1 here. Okay, firstly we will take VC at 0 volt, and secondly we will take VC at 1 volt, and at 0 volt for different input voltages we will just check the values of VB and IB here, and here at 1 volt of VC we will take different values of VB and IB here. Okay, so this is for input characteristic. Now for output characteristic, what I am going to do, I will just keep this IB constant, as already I have said, this IB should remain constant. Okay, so when IB will be constant, at that time what we will do, for different values of V2, okay, for different values of V2 we will measure the value of VC and IC. Okay, just see here, firstly I will make my IB is equal to 0 microampere. Okay, and at 0 microampere I will check the values of VC and IC for different values of V2. Okay, and secondly when IB is equal to 10 microampere, at that time what I am going to do, I am again going to take the values of VC and IC for different values of V2 here. Okay, so for making this IB here 10 microampere, what I am going to do, I will just change little bit voltage of V1 here. Okay, by changing the voltage of V1 here, I would get a value of 10 microampere here. I will check that at which value of V1 this IB becomes 10 microampere, and I will keep that V1 voltage constant. Okay, for this second part of this observation, for this observation what I am going to do, for whichever value of V1, okay, I am going to get IB is equal to 10 microampere, I will set that V1 constant at that value. Okay, and then I will change the value of V2, and for different V2 voltages I will measure the value of VC and IC. Okay, so this is my experiment. Okay, So in the graph you have to draw the graph by taking the observation. Okay, we will plot the observation in of course in Excel. Okay, it would be easier for us. Now I am going to draw the circuit in multisim and I will show you how to uh, perform this experiment. Okay, so now I am going for the multisim part. So here firstly I am going to take a transistor here. Okay, so no, I'm not going to find it, it would take much time. So since I have already found out this BC 548 one time, so it has came here. Okay, since I have chosen here all group, the value would come here. Okay, that transistor. Okay, so this is my transistor, NPN transistor. Now I am going to use here resistance. Remember, in resistance part you have to choose this from this basic only. Okay, because if you are going to write here 1 kilo or 100 kilo, so the 1 kilo or 100 kilo or 10 kilo would be anything, the value of capacitor, the resistor, the inductor would be there also. Okay, so this thing you have to find it by the help of this basic tool only. Okay, so these two things I have chosen. Now I am going to choose a voltage here. Okay, so from the source I am going to choose a voltage here. Since I am going to change the value of DC voltage in V1 part, so I am going to use here DC interactive voltage here. Okay, and for this part, for V2 part, I am just going to add a DC power source here. Okay, now I would need ground also. Done. So these are the components which we are going to require for the experiment. Okay, so I'm going to connect it here this. Okay, so 100 kilo ohm, I would also need a 1 kilo ohm resistor here, so I'm going to copy and paste this thing here, and I'm just going to change the value here to 1 kilo ohm. Now remember, we need to take the value of voltages and current also, so we are going to use ammeters here. Okay, and voltmeter also. Just look at here. Here you can find here the ammeter. Two ammeters are there for measuring IB and IC current. Okay, and two voltmeter are there for measuring VBE and VCE. So here I am going to connect this one here. And this thing I'm going to connect it here. This emitter I am going to join here. So just look here, I have used two ammeters here. This one would be the ammeter which will measure the IB value, and this ammeter will measure the value of IC here. Okay, so we do need two voltmeter also. So 1 voltmeter here and 1 voltmeter here. Okay, so this is my whole of the circuit. This multimeter, from this multimeter I am going to measure the voltage of between B and A. So it would be called VBE, and this multimeter, by the help of this multimeter, I am going to measure the voltage between this C and E. So this would call VC. Okay, so these are the whole components, and my circuit is ready for further purpose. Okay, so for first thing what I am going to do, firstly I am going to make this thing 0 volt. Okay, just look here at 0 volt of this thing, and here I am just going to change this value. Okay, the increment I would take up to, I would make 2.5% of this thing. Okay, so firstly this 5 volt would be decreased to 0. The key is A here. Okay, so when I'm going to press the keyboard A button, this voltage would increase. Okay, so firstly for 0 volt, when you are going to run this thing, okay, we will get 0 ampere and 0 volt here. Okay, just see here. Okay, this should be on A. Okay, so that this could act as my ammeter. Okay, so these both upper ends are the ammeter and these lower ends values are for voltage. Okay, so now I am going to increase the value of voltage here. So just see here at 0.25 voltage of V1, we can see here that the current here, just look here, the current here is in picoampere, and here the the IC current here, it is also in picoampere. So the value of picoampere current is very low. Okay, so we could neglect this part. Okay, when this will come above that part, we can consider it. Okay, and here just check here the voltage. Here the voltage is in femtovolt. Okay, so this voltage is absolutely very low. Okay, so when this is very low, we are not going to consider this thing also. Okay, we will consider the voltage when it will come in micro volt. Okay, now again I am going to increase this V1 voltage here. So at 0.5 volt also this current is in nanoampere, so it is in 3.316 nanoampere. So this could be considered as 0.3, okay, 0.3 microampere. So we could consider this current here also. Okay, we will not consider this value of voltage here, we will consider this thing as 0 only. Okay, we will consider that the voltage of VCE is 0. Okay, as in the experiment I shouldn't change the value of VC, this VC should be constant. So since the value of VC is very low, okay, so we are going to neglect this thing and we will consider this as 0 volt only. Okay, so here we could consider here the current to be 0.3 microampere. So this could be taken here, and here just you could see here the value of voltage here is VB is 468, okay, millivolt. Okay, so we will consider this value also. Okay, so we will take different values of this IB and this VB, okay, for plotting the graph here for the input characteristic. Just see here, for the input characteristic we do need the value of VB and IB. Okay, for one set of values of VC is equal to 0 volt, and for one set of value when VC is equal to 1 volt. Okay, so we have gone up to this part. Okay, now what I am going to do, I am again going to increase here the value. Just see here, when you are going to increase this value, okay, so the values here are changing at this IB and this VB. Okay, here this multimeter is showing voltage in picovolt. Okay, 9.195 picovolt here, this VC. So this picovolt is very low. Okay, so we are not going to consider it. Okay, so just move it up to 5 to 6 volt or 7 volt. Okay, so up to 7.5 volt also you are saying this VC is in picovolt only. Okay, so we are not going to consider this value. Okay, we will consider this thing at 0 volt only. Okay, as VC is 0 volt. Okay, so we are considering this value of voltage 35 picovolt as 0 volt only, because this value is very low. Okay, and we have got these type of values, the 68.674 microampere of current here as IB, and this VB is 632.554 millivolt. Okay, so we will take around up to 10 volt different observation, and afterwards what we are going to do, we are going to change here this value of voltage, okay, this V2 for second set of observations, okay, in the input characteristic also. Now at this time you are seeing here that this V2 is 1 volt. Okay, so when this V2 is 1 volt, what we will get when we are going to run this circuit here, just see here this VCE is showing 1 volt. Okay, why is showing 1 volt? Because it is directly connected to with this V2 volt. Okay, so at this part this VC is 1 volt, and again we will change the value of V1 here. Okay, these are different set of values, and for different set of V1 we are going to measure this VB and VIB. Okay, so just see here, I will just increase the value of this V1 here, just see here, and we are going to get different values of this IB and this VB. Okay, so for 1 volt of VC we are getting different values of IB and VBE. Okay, so we are going to use these type of values to fill this observation table, and we will plot the graph. Okay, now for doing the output characteristic, firstly what I am going to do here, I am going to change the V2 here. Okay, so since I am going to change the V2 here, just see here, I have to keep this IB constant at 0 microampere. So for 0 microampere, if the current in this part is 0 microampere, so this means that this value of voltage should be here 0 only. Okay, so I am not going to increase the value of voltage here. Okay, I am going to change the value of voltage here only. Okay, so since I am going to change the value of voltage here, so I am just going to replace it by DC interactive. Okay, so it could be easier for me to change the value of voltage here. Okay, so just look here, I have replaced it by DC interactive voltage, and here I am going to just change the value of increment by 2%. Okay, so this is here, you could see here when I am going to run this thing, so at 0 volt of input, okay, this current here is very low. Okay, so we could neglect this thing and we could consider it as 0 volt only. Okay, so here the value of voltage is very high, so just I am going to firstly decrease this value. Okay, so at 0 volt everything is 0. Okay, now I am going to increase here the voltage of V2 by key A. Okay, so you could see here the current is in picoampere. Okay, so we could neglect that current. Okay, so here you can see that the current here is changing. This 3.706 microampere current is coming here. Okay, when I am going to change here this A. Why this happening? Because this is key A also, and this is also key A. Okay, so when I am going to change here, when I am going to press A here, this is also changing. Okay, so what I am going to do, I am just going to replace this A by B. Okay, and then again I am going to do this thing. This error was coming because when I am going to, and when I was pressing A there here, this value of voltage was also changing. Okay, so now I am going to run this thing. So just see here at 0 volt of V1 and V2, everything is 0. Okay, so now I am going to press A here. Just see here, this current in IB is very low, so we could consider it at 0 ampere here. I am going to increase this voltage of V2 there. Okay, so when this V2 voltage is changed here, just see here the current IC and the voltage here. Okay, just see here this IC voltage, this IC current which we need, we are getting, and here we are going to give the values of those IC, and this VCU also we will give it the value. Okay, so here just we are going to change this value. Just see here, in all those values we are getting here the IB as very low. Okay, so we are not going to consider this IB current. Okay, we will consider this thing as 0 only. Okay, so we are going to increase the value of V2, okay, up to around 10 volt. Okay, so just see here the current is very low in all that case, so that means that for IB is equal to 0, we have taken these type of value. Okay, so these two values you will use to fill this observation table. Okay, at IB is equal to 0 microampere, and now I will make this IB is equal to 10 microampere, and in that case what I am going to do, I am going to fill this VC and IC. with different values. Okay, so for that thing what I am going to do, I am going to increase this value of voltage so that this current, this current IB would become 10 microampere. So for that thing, firstly I am going to make this thing 0 volt. Okay, this thing is also 0 volt. So firstly what I am going to do, I am going to see that at which voltage of this V1, this current IB is going to become 10 microampere. Okay, so I will increase this voltage. Okay, sorry, I have, but wrongly I have pressed key A. I would press B. So just see here, I am changing this value of V1 here. Okay, and the current here in IB is increasing, so it became 9.269 at 1.5 volt. If I am going to again increase this to 1.75 volt, this voltage has increased, this current has increased to 11.699. So I do need 10 microampere. Okay, so firstly I am going to change this thing, this V1 by DC voltage firstly. Okay, so that I could feed here any value. Okay, so here I have seen that at 1.5 volt I was getting around 9 point something current microampere. So here I am going to use 1.56 suppose, and let's run this thing. I am getting 9.851 microampere of current. So I would just increase this value of voltage here somewhat more, around 1.58, and again I am going to run this thing. Okay, so at this thing time it is coming 10.0445. So I would make this value of voltage to 1.57 volt. Okay, so here at 1.57 volt, okay, at 1.57 volt this value of voltage is low. Okay, so I would make it 1.58 only. Okay, so no need to change that thing. So look here, at 1.5 volt of V1, this 10 IB is 10, around 10 microampere. Okay, so now we are not going to change this value of V1. Okay, we will change the value of V2 here, and we will, for different values of V2, we will take the values of this IC and VCE here, and then we will plot the graph. Okay, so firstly initially just see what happens when we are going to change the value of voltage here. Okay, when I am going to change here voltage, just see here the current here decreases. Okay, firstly it decreased. Okay, now it decreased to 9.773. If it had decreased very low, I wouldn't have considered it, but it has decreased somewhat. Okay, so again I have to make this current to 10 microampere. Okay, so at 0.2 volt also I do need to make this thing different. So for that thing I am again going to change this value of voltage. Okay, so first observation you would take at 0 volt. Okay, at 0 volt everything would be 0. Okay, and now at 0.2 volt just don't take these observation. Okay, because at these observation this value of current here it's not 0. Okay, so my first observation at 0 volt would be 0. Okay, so we will not take that observation also, because we do need to have this 10 microampere value. Okay, so I'm just going to change here some value of V1 here. So just I would make 1.59. Okay, and run this thing. It is coming 9.872 again. Okay, so again I am going to change here this value, just take it 1.6. Okay, it is coming 9.971. Okay, so I would just increase it somewhat, again 1.62 suppose. Okay, so when you will make this 1.2, just see here I am getting 10.168 microampere. So this could be lower. Okay, so I'm just going to make here this 1.61 volt here. Now when I'm going to run this thing, just see here, I am going going to get 10 microampere approximately. Okay, so this 10 microampere is now good. Okay, so my first observation would be at when this was 0 volt and this was around 1.57 or 1.58 volt. Okay, at 0 volt and here 10 microampere, we have seen that what was the current here. Okay, remember my first observation would be when IB was firstly 10 microampere. Okay, at the initial time. Okay, when this value was around 1.56 or 1.57 volt, and at 0 volt here I have got some value of current here. Okay, so my first observation would be that only. My second observation would be this thing. Okay, at 0.2 volt, okay, this current is here and you can see the voltage here. Okay, so this would be my second observation. Okay, so for initially for some value of this V2, what happens now? This current IB changes little bit. Okay, but afterwards what happens? This current is not going to change very much. Okay, so again I am going to press A here. So just see here, it changes little bit. Okay, so I could leave that thing. Again I am going to press A here. Okay, so just see here, I am increasing the voltage, but here the current, it is changing very little bit. Okay, so we could ignore that thing. Okay, and for different part of value of voltage here in A part, just we can see here that we are getting different values of this current and this volt here. So we are going to use this voltage and this current, okay, to fill here by this observation, and we will consider that IB is around 10 microampere only. Okay, and when we are going to change the value, just look here, the current here became 9.5. okay, so since at this time the current became 9.5 and 5 microampere, so this needed to be rectified. Okay, so for that thing, what I am going to do, I am going to again make it around 10 microampere. So for that thing, again I am going to change here this V1 voltage. Okay, so it is 1.61, just let make it 1.64 here. Okay, so it is around 9.926. okay, so this is around 10 microampere, we could consider it as 10 microampere current. Okay, so again we would change the value of voltage here. Okay, it V2. okay, so just look here, I'm again changing here the value of voltage. Okay, so just don't let this current to be lower from 9.7. okay, because 9.7 microampere could be considered nearly to 9.99 or 10 microampere. Okay, if you are going to lower this value up to 9.5 microampere, so that could be error. Okay, so don't allow this current, this IB current to be lower from 9.7 microampere. Okay, so if it is going again lower than that thing, okay, just change the value of voltage here. Understood? And then again just increase the value of voltage here. So just look here, at 7.4 volt here also, just look here, the value of current here, that IB is not going to change here, 9.729. As already I have said that initially somewhat for different values of V2, this IB current changes little bit, but afterwards what happens, this IB current remain constant. Okay, it is not changing with respect to this V2 voltage. Okay, but here the current IC and this VC would change. Okay, so we will take the value of IC and VC. Understood? So these values we will use to fill up this graph. Okay, and then we will this observation table, and then we will draw the graph. Okay, so this was our experiment. Okay, so at the end you have to draw the graph here also. Okay, by the help of Excel. Okay, so the harder part is this one only, which I have understood while doing the experiment. Initially when you are going to get this IB at 0 microampere, remember this V2 voltage should be 0. Okay, this V2 voltage should be 0 when this IB current is 10 microampere. Okay, then increase this V2 current somewhat. Okay, you will see that this value of IB it will change somewhat. Okay, so don't worry at that part. Okay, but if this value changes very much, okay, then you have to again make it to come around 10 microampere by changing this value of voltage. Okay, so you will change this value of voltage so that this current could become around 10 microampere. Okay, and at nearly about 10 microampere only, just change the values of this voltage and take the values of this current IC and this voltage VC to fill up this part of the graph. Understood? So this thing just do and draw the graph here. By the help of Excel you could do that kind of thing. Okay, and at last I have written a result also. You have to write the conclusion here. Okay, that what is happening. Okay, I hope you have understood that what you have to do in the observation. Okay, thank you for watching.